Greetings, Algebra 2. We are going to be working on section 11.2, polynomials and geometry. So, we've learned about polynomials in the last section, but let's go ahead and further define polynomials with different numbers of terms. So for your first vocab word today, you have monomial, which is a polynomial with one term. And to give you an example of what that looks like, maybe a different color pen here. Alright, we'll use that. So a polynomial with one term would just be like x, one term. Or it could be 3x squared. Okay? Or, it could just be 7. It doesn't have to have a variable. So either a variable and a number, or just a number. Alright, but those are each one term, so that's why they're all monomials. A binomial would be a polynomial with two terms. So for example, you could have x plus 4 as a binomial. You could have 5x to the third power minus 2. All right, each of these has two terms separated by a plus or a minus sign. So that's how we know it's a binomial. Trinomial is a polynomial with three terms. So you would just add another term on. So for example, you would have x squared plus 3x minus 1 for an example. Or you could have x plus or minus 7 plus y. Whatever you have, it has to have three terms, separated again by either a plus or a minus. Okay, so example 1 says the width of the townhouses pictured below are x, y, and z. So we have three townhouses. Here's 1, here's 2, here's 3. And the width is, for this one, it's x. For this one, it's y. And for this one, it's z. So we actually don't know the width of any of our townhouses here, but they are represented by these three letters. Each has a height of f plus s. So we have our first floor here and our second floor here. So the total height that you have is f plus s. Okay. Find a polynomial for A, the total surface area of the fronts of the three townhouses. So we need to find the area of this shape that we're asked to find here, which this shape is a very simple rectangle. And if you remember, the area formula for a rectangle is just area equals base times height. Okay. We already have our height. It's f plus s. Now for our base, we have to take the whole base here. So that's going to be x plus y plus z. And that's our base. Now we take these two measurements and we plug them into our area formula. So we get A equals, our base is x plus y plus z. And our height is going to be f plus s. Okay. So we take these and we just multiply these polynomials. Now, when you are multiplying polynomials, you essentially just have to make sure everything in the first gets multiplied to everything in the second. So there is obviously a systematic way to do this. So what I like to do is I like to start with the first term, multiply it by everything over here. So x times x is xf. And then we have to multiply it by that guy, which is s. So x times s is xs. And then since I've hit both of the things in the second with x, I'm done with x. So I move on to y. So y times f is yf. Y times s is ys. And we're done with y since we've multiplied both of them over here. And finally, we have to do z. So z times f is zf. And then z times s is zs. Okay. So this actually represents the area of our entire front surface of our townhouses here. I know it's kind of odd to look at all these letters and say, hey, what does that even mean? But essentially, if we knew what x was, we knew what y was, we knew what z was, and then of course, if we know what f and s were, we'd be able to actually find a number for these, for the area of our townhomes. But since we don't have numbers, we just have this polynomial that represents it. Now, if you're looking at this guy, it has 1, 2, 3, 4, 5, 6 terms. So it's a 6-term polynomial. So it's not a monomial, binomial, or trinomial. We only go up to tri. So anything beyond that, you just say it's a 6-term polynomial. Now this guy's degree. Now each one of these has an exponent of 1. So we have x to the first, f to the first. Now the degree of this whole term, though, since there's two different variables, you have to add those together, so the degree of this term is actually 2. Oops, sorry. It's actually 2. And the same for the rest of these. We have 1 here and 1 here, so the degree of this term is 2. We have 1 here, 1 here. The degree of this term is 2, so and so on and so forth. So the highest degree we have out of all of these is 2, so it's degree 2, or the second degree. So 6-term, second degree polynomial. Alrighty, and we're going to save the rest of the examples for the next video, so please join me there.